Dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 481. In this lecture, we will try to understand time and space complexity of k-means algorithm. In k-means clustering, there is no train and test because you are just clustering. It is one time. So let's look at the time complexity. So what you are doing for simple k means, look at simple k means it is order of n into k into di. Let's understand what these are. N is the number of points, k is the number of clusters, d is the dimensionality of your data. I is the number of iterations because what you are doing literally is in each iteration you are computing the distance from each point in the data set. How many points we are assuming? N points. From each point to each centroid or to each cluster. To compute the distance, what you need? To compute the distance, I need this one. To compute the distance, I need order of d, isn't it? Because each data point is d-dimensional. Each data point is d-dimensional vector, I can say. It is d-dimensional vector. This is the whole thing. Order of n into k into di is your, what is this? This is time complexity, isn't it? Typically, your k is less than or equal to 10. Not necessarily always. Typically, k is small and number of iterations I is less than or equal to 300. Typically, not necessarily always. If you say that your I is not too large, I is not too large. I is not too large, and your k is also not too large. Is not too large. Yes, I is not too large, k is also not too large. Dimensionality is anyway there. This can be approximated. This order of nkd can be approximated order of nd, isn't it? If n is very large, here n is very large. N is very large. Let's say n equal to 10,000 k, 10k points. Otherwise, let me say n equal to 100k points, isn't it? Let's say d equal to 1k. Let it be, isn't it? 1k dimensions. So, as compared to n and d, your k and I are very small. As compared to, I will repeat, as compared to n and d, your k and I are very small. These are very small. Your k and I are very small. These are very big values. Whereas n comma d are very big values. That's what it says, isn't it? Order of nd. This is said to be still linear, isn't it? What is this? This order of nd is linear time complexity. Let's see. This is order of nd, which is linear time complexity. This is said to be still linear in time. This is still linear in time complexity because still it is linear in number of points and number of dimensions. As per as space is concerned, you still have to store all of your points and d. You also have to store you also have to store what you have to store. You also have to store k-centroids. I will repeat. As space is concerned, as far as space is concerned, you still have to store all of your points and D. You also have to store k-centroids. That is order of ND plus k. That's all you need to store. You need to store your k-centroids. You need to store your n data points. This is still again linear. Again, assuming that k is much smaller than k is, what is k? K is centroids, n is data points, k is much smaller than n. K is much smaller than n. This is also approximated as order of ND, which is also linear, and it is not quadratic. It is not like order of n square, n cube. It's not polynomial. It is just linear in n and d, which is very good. So k-means is quite fast. Actually, in real world applications, k-means is quite good and quite fast. So you don't have to worry about space and time. Anyway, you need to store all of your data points, that is ND, to start with. So this k-centroids looks like trivial in terms of space complexity, in terms of time complexity. Your k and I typically significantly smaller than your number of data points n, and dimensions d is quite and dimension d is quite large. The reason lot of people like k-means is because it is fast. So it's one of the reasons why it is very popular, very simple to understand. People who do not know even basics of machine learning can understand what is centroid is, what a cluster is. It's very simple idea, hence people like k-means. Thank you very much.